Good morning, friends. So we'll start chapter 9, Magnetic Particle and Methods of Application, Introduction. Particles having high permeability are easily magnetized by and attracted to low-level leakage field at discontinuities. Low retentivity is required to prevent the particle from being permanently magnetized. So iron particles, iron oxide powder, the particle in the magnetic particle testing. These have high permeability and easily magnetized by and attracted to low-level leakage fields at discontinuities, low retentivity. So these are the powder material. And size 0.002 to 0.006 inch, 50 to 150 micrometer for dry particle, and 0.0002 to 0.0006 inch, 5 to 15 micrometer for sensitive wet technique particles in commonly used formulation. So these are bigger, these are smaller. So these are good for fine discontinuities. These are good for outside high temperature and subsurface discontinuity with HWDC. These are dry powder, these are wet powder. Don't forget things for this book. Otherwise you will be having problem. Even with this, wet fluorescent is better for fine fine surface cracks, AC or HWDC. Anything there, you can mark what is the you can choose. If it is surface subsurface, HWDC is better. If it is only surface, you can go for AC. It is up to you what you choose. Elongated particles are inclined, particularly in the case of dry powders, because these rod-shaped particles easily align themselves with leakage fields not sharply defined, such as those occur in over subsurface discontinuities. Globular shapes are included to aid of mobility and uniform dispersion of particles on a surface. Wet media using either water or high flash point petroleum distillate dry powder can select an appropriate color contrast based on the test object surface. Colors for use with ordinary visible light are red, gray, black, or yellow. Red and black particles are used to wet parts with ordinary light, and yellow-green fluorescent particle with ultraviolet radiation. There are many different colors for contrast. So red, gray, black, or yellow, depending on the surface. Or you put white contrast, it is up to you. In fluorescent, you definitely don't need. Though there are some glass powders they can use for developer, but they not for empty. Sorry. Use wetting agents. Wetting agents, rust inhibitors, deforming agents. You can put inside this. If you are preparing yourself, you can put all these things. Or else formulations are coming from good companies, so you don't have to worry for these things. The wetting agent to wet the surface, rust inhibitors, so that it will not rust, deforming agents, so that it will not form foam. If no rusting can be tolerated, higher concentration of rust inhibitor is used. Test object have an oily film, more wetting agent is required. The test object surface will comply, wetted and covered with bath. Breaking a bath into rebullets as it applied over the test object is an indication of need for test object cleaning. Okay, dry applications. Magnetic particle and dry foam may be applied by hand using rubber squeeze ball, plastic squeeze bottles equipped with perforated caps similar to ordinary salt shakers but with smaller holes. Dry powder is also applied using handheld guns and compressed air. It is too much, I don't know. The continuous and residual method, current level and particle application. Highly retentive test objects may be tested using residual method. Low retentivity test objects must be tested using continuous method. For test objects having extensive grinding fatigue or heat-treated crack, 0.5 to 1 S is usually enough time for 1 second. Usually enough time to form visible indication, particularly when the media is fluorescent. Test object made for low retentivity stills may have wet method media applied while they are being magnetized or magnetic current is running. That is continuous method. Short asymmetric object, encircling coil and direct current, elongated cylindrical object, encircling coils, flat surface, yoke method, prod method, cracking at thread root, both active and residual magnetism. When the magnetization force is removed, the residual magnetism in the test object is always less than the field present while the magnetizing force is acting. The continuous method for a given value of magnetizing current is always more sensitive than residual method as determined by strength of field in the test object. The continuous method can be used with direct contact method, the central conductor method, and coil for longitudinal magnetization. The test object should be flooded with wet media before the current is applied and the media stream is turned off or diverted from the rest test object before the magnetic pulse end. So continuous wet method procedure. In some instances where large forging of steel casting are to be tested using the continuous method with bath application by a hand hose, magnetizing current may left on from a 5 to 10 seconds, during which time the test object may be repeatedly swept with the bath spray. The magnetizing field is maintained for 1 to 2 seconds after the final spray has ceased to or been diverted. The continuous method implies the magnetizing force is acting while the magnetic particles are applied. Some cases, usually when alternating current of half wave direct current is the magnetizing current, the current is left on, sometimes the minutes at a time while the magnetic particles are applied. The heavy current required for proper magnetization can cause overheating of test object and contact during burning or damage to the equipment. In practice, magnetizing current normally only for 0.5 second to 1 second. So these are one reason why the viscosity of the bath and bath concentration is so important. Bath concentration, they are calling this viscosity. Anyway, bath concentration is very important. You have to follow as per the requirement. So anything that tends to reduce the number of available particles or slow their movement also reduce the buildup of indication. Residual method. Residual testing requires test object to be retentive enough to hold magnetic particle indication at discontinuities. Detention of surface discontinuities requires stronger leakage field at the site of a discontinuity while the test object being magnetized and when the continuous method is used. Residual testing permits the magnetizing of test object at one time and application magnetic particle media at the subsequent time. The central conductor method is used. Testing of holes, pores is facilitated since testing takes place after removal of the central conductor. If it is residual, it is nothing like that. So residual weight method. Magnetic particle testing media may be applied by stream spray immersion of the test object in a tank. Too weak the particle concentration will produce weak indication, and the borderline cases may cause fine discontinuities to go undetected. Too heavy concentration produce heavy background accumulation, reduce color contrast. In some cases, on bearing rollers, for example, formation of fine indication may be enhanced by immersing the magnetized test object in liquid media for a considerable time. This gives leakage field time to attract and hold the maximum number of particles, resulting in an increase of sensitivity. So, use of dry powders residual method. Not so good. Apply the interior surface of test object that with wet media. Completely cover the test object in a short time. So, field direction for circular magnetism. Discontinuity is located in the direction of magnetic lines of force have the lowest probability of detection. Discontinuity is perpendicular to the magnetic lines of force have highest probability of detection. This you have to remember. Hall effect meter. The Hall effect Gauss Tesla meter. So one flux line per square meter is 1 Gauss. Tesla meter is a versatile magnetic field indicating instrument. It applies a current to Hall effect probe or sensor and amplifies the output voltage that is proportional to the measured magnetic flux density. It is a laboratory instrument and relatively fragile. It doesn't withstand normal use required in a magnetic particle testing shop. It measures only flux passing through the probe or sensor at right angles. Placing the probe on the test object surface merely indicates the flux at that point and doesn't measure the field in the test object surface. Pi gauge. Qualification of pi gauge is responsibility of level 3 technician. There is 8 low carbon steel pi sections furnace brushed together and copper plated. There is different sizes. You have to follow section 5. The device is essentially the disc 5 permeability material divided into 4 or more sections, mainly 8, by equally spaced cuts that simulate discontinuities. So you can form indications when you put in a magnetic field that you have to find the field is there or not. Adhesive indicator. Small metal adhesive indicator. Indicator is a silicon iron material and measures about 0.5 inch, 13 mm long by 0.25 inch, 6 mm wide by 0.01 inch, 3 mm thick, a 0.003 thin, 0.08 mm square slot is cut across the 0.25 inch diameter. So for all these things, you read for section 5. If I have time, I will. Of course, no magnetic poles are produced in the test object. Poles will be produced if test object is not a concentric cylinder. Test object is irregular except or path of current flow is not located in the test object's geometric axis. So no magnetic poles are produced in the test object. However, if the test object is cut, such as a keyway is made, some of the field will pass out over the cut, producing opposite magnetic poles on each side of the cut. Such poles can hold chips or metal that can interfere the subsequent machining operation or damage bearing surface. Direct contact method, passage of electric current through the test object themselves. Central conductor method, passage of current through a conductor that in turn passes through the test object. Damping heads, lead faceplates or copper braid plates must be used to prevent arcing, overheating, sputter. Wetting of the contact plates with the suspension media before current application helps to prevent overheating. Central conductors are any high conductive material such as a copper bar or cable. Theoretically, the magnetic field is zero, the inside surface of such test objects unless the central conductor is used. Central conductor method, it is very useful for detecting discontinuities, usually cracks, which form radially out of holes in castings. A test object with a hole or opening to the tested for inside and outside discontinuities usually positioned with the conductor centered coaxially in the hole of opening. Very large test objects having large openings, central conductor may be located close to the inside surface, and several tests may be made around the inside periphery of the opening. The type of equipment and capacity available, amperage, the type of discontinuity and its expected ease of difficulty detection, test object size, shape and cross-sectional area through which the current will flow, amount of heating that can be tolerated in test object at the current contact areas, direct current amperage. The testing of amperage should be 300 to 800 ampere, 12 to 32 ampere per meter of diameter. Test object is reasonably uniform and cylindrical in shape. These are for headshot. This is per inch diameter. This is per mm of diameter. So how many inches your diameter depending on you multiply. Central conductor is different than headshot. This is headshot. The central conductor is 100 ampere, 4 inch. It is 4 here, 4 ampere per mm. Hole diameter to as much as 1000 ampere per inch, 40 ampere per mm. Depending on the test object, material and nature of the suspected discontinuities, the strongest flux field is present in the part's inside surface. The central conductor is located. Magnetizing field strength on the inside surface of the part decreases. The distance from the central bar conductor increases. Radial discontinuities at the edges of the holes and openings can also be detected using central conductor methods, since some portions of the magnetic lines of force will intercept these discontinuities. Use of equation 1 to determine the number of times test object must be rotated in equal movement and remagnetized to ensure complete testing has been obtained. If it is bigger size, very big size, so S is the number of turns required to complete overlapping of coverage. Only pi d by 4 is enough, but here they increase it like, so inner diameter of central conductor is dp. If you are taking for central conductor, it is central conductor. You're taking outer diameter of coil, you take diameter of coil, so you can take one. Inner diameter of the central conductor by outer diameter of central conductor, 0.9 dc. Or outer diameter of coil by inner diameter of coil. So you have, if you are telling really it is central conductor, there is only one diameter. Why they are just using, I don't know. It is coil, if it is different diameter. It is slight higher, and it is smaller. Because this is inner diameter of the coil. For central conductor, it is same. There is no, if it is not a tube type thing, there is nothing, central conductor only. Longitudinal magnetism. Coil set. The usual way for longitudinally magnetized test object is by placing the test object in a rigid coil on a stationary magnetic particle testing unit. Coil shot, not telling. Multiple coil shots. Because the effective field it extends 6 to 9 inches on either side of a coil. Multiple tests are needed on long test objects. Well, it may be difficult. I don't know. Where they fit this thing. If they can bring out, okay, they can do it. Cable wrap. Cable wrapping a coil around large or heavy test. Oh, this is coil short, so no problem. They can just pass on. Cable wrap. Cable wrapping a coil around large or heavy test object is common practice. Flexible insulated copper cable is used. Cable wrapped coil is connected to a magnetic particle mobile machine, portable power pack, or it can be connected to the contact heads of a stationary test unit. So that is also possible. Longitudinal all. Amperage for a longitudinal magnetization. The coil diameter and number of turns. The length of diameter ratio, test object, size, shape of the composition, the test object, position of the test object within the coil, kind of discontinuities being sought and their ease of detection, magnetic coupling component or fill factor of the coil to the test object, the magnetizing field strength H in the center of the magnetizing coil increases or decreases in direct proportion of the coil current. Also, the field strength decreases if the coil radius is made larger, increases if the radius is made smaller. The field is theoretically zero in the coil center and increases to a maximum at the inside edge of the conductor. Already we've seen the figure, so I think it is enough to explain amperage of the magnetizing current, control of magnetic particle, testing media, sensitivity level, sensitivity of the magnetic, and the concentration. Concentration should be much good than sensitivity. Many things missing. I don't know. Amperage too low. Many produce leakage fields too weak from readily discernible indication. Amperage too high. It should be in between. Creates a heavy background accumulation of particles that may mask an indication. Wet method media, because of their smaller particle sizes, are the most sensitive for detection of surface discontinuities. Dry powders are better for detecting subsurface discontinuities. Fluorescent magnetic particles have higher apparent sensitivity than those used for white lights, such as black and reds. Fluorescent indications are more easily quickly seen in darkened area of ultraviolet radiation test. Particle concentration in the baths must be closely controlled if the maximum sensitivity is obtained. Sensitivity is lowered if the concentration are too low because lack of sufficient magnetic particles to be readily discernible. If too high, fine indications may be masked by heavy background accumulation. Contaminants, particularly in wet baths, can result in lower sensitivity. Lubricating oils and grease cause a blue background fluorescence that reduce contrast, causing fluorescent particle indications to be less visible. Sensitivity of dry particles powders depend on the type of powder selected. The light tossing and air blowing action is needed to allow particles to migrate and be held by the leakage field at discontinuity is dry powder. So sensitivity in dry powder depend on type of powder selected. Excessive application of powder can cause indication to be lost in the background accumulation. Magnetic flux density. The magnetic flux density is the product of magnetic force, magnetic permeability of the test object at any given point. We'll stop here.